polygons were we talking about yesterday?
Parallelograms. Any
Quadrilaterals.
Quadrilaterals. Who can put up the area formula for a quadrilateral? Raise your hand so I can give you a marker. Who can put one of these up? Jason, put one up. Write down what it is next to the formula that you write down. Who's got another one? I know you don't know what Jason's going to pick yet. Who's got another one? Zach? Kylie?
You want us to draw a picture?
No, I just want write square and then tell me what formula you've got.
No.
That's right, leave it. Leave it! Oh! Write it back, write it
I
back.
thought you meant what we did
Because
yesterday.
we're going to use that too. Who's got another one? I'm out of colors. Square. Perfect. Quadrilateral. So we're going to change that to a different
I thought
name.
you meant what we did yesterday. What area things we did yesterday?
Can we do
Yeah, well, you were wrong.
We're going to change this one to rectangle.
Did you say I could do one?
Wait,
How
sure.
is that wrong?
Because she wanted
Kind of
quadrilaterals.
I asked for quadrilateral.
I thought she said that what we did yesterday.
Woo, got it. What else?
No, we didn't. We triangles. Those are quarters.
That's a quarter.
Those are quarters.
Okay, I probably owe them $5. Dude. Yeah.
Adam. You probably owe me $5.
Yeah, I know.
That's $5 there.
Parallelogram. So we have one left.
Rhombus.
One more.
Okay, I'm doing
Rhombus,
that
who
one.
knows what
No,
it is?
I'm doing it because I have a marker.
You're right. Very good. So today, our objective is to figure out where those formulas come from.
Oh, there it is. Right
She
there.
crossed out quadrilateral and right rectangle.
You want me to erase it?
Nope. I want you to write wrong. Okay. So yesterday we got all of these formulas, and today I want to show you where they come from. But really, I want you to show me where they come from, so that when we're writing them, we know exactly where they came from. This is going to be very important for us to be able to do that. Thank you. So, postulate 19, can we read that? They're too small.
You can
Yes,
write.
we should write this down in our notebooks. Postulate 19, can we read what it says? Yes. You want me to say it anyway? Good. Postulate 19 says area addition postulate. That should tell you some things about what that postulate does. Area of a region is going to be the sum of the areas of its non-overlapping parts. Okay? This picture illustrates what this postulate says very well. I have a big picture that looks like that, and I can separate it so none of its parts are overlapping and do two separate areas and add them together to get a total. That's what this postulate is supposed to be doing. Does this make sense?
Were we supposed to do this on our homework too?
No, this was not on our homework from last night. Should not have been adding things together. Unless you had a trapezoid, that's the only formula we have where we're adding things together.
Wait, then I did some stuff wrong.
Well, we'll figure that out later.
Turn in our homework.
We are going to turn our homework in later. But right now, we're going to focus on area addition postulate. And maybe if we get the area addition postulate and figure out where these formulas come from, our homework won't seem so daunting or scary.
Oh, I didn't ask for help.
Excellent. Questions on area addition postulate? So if I change it, because I sort of flipped our object upside down, if I change it, and I say that this area is 12,
I'm like joking.
and this area is 8, what would the total area of that shape be? 20. I'm just adding the different parts together. Yes. Good.
Should we write this down?
So you want a picture to go with your postulate? Either this picture or this picture. Yes. So what we're going to do today is we're going to take our shapes that we talked about yesterday, and we're going to either try to split them up into 2 different parts, or 3 different parts sometimes, or copy them and put them together, okay, and see what we can come up with and why our formulas make sense. So, what do you think we're going to start with? What did we start with yesterday?
A square.
We started with a square, so that's what we're going to start with today. The area for a square is side times side. So, go ahead and give you your paper. So your paper, squares like your given. So remember when we did proofs and you had givens, and then you found an answer later? Our square formula is going to be our given. Okay? So if we follow this paper, we're going to start with square, but I'm giving that one to you. So your next job is to figure out rectangle.
For Kasha and I came over, we like wanted to have maybe like it'll take, we'll say 12, and then it will give like, it won't give 8, but then it'll say 20. Do we have to just
Square, that's square.
subtract 12 from 20 and back to that?
No, I don't have any like that. But you've just given me an idea. Good. Good. So, if you read your paper, it says investigate and determine the area formulas for polygons. As soon as you find an area formula, you can use this one to help you determine subsequent formulas. That means we're going to start with square, and that's given to us. It's area is equal to side squared. I'm not going to ask you to figure out where side squared came from. But the next one is going to be for a rectangle. In rectangle, we know that that area formula is length times width. I want you to use the square formula to figure out how length times width, how we can come to that conclusion that the area of a rectangle would be length times width to figure it out. Okay? Okay, so let's do rectangle together. And I have this for rectangle, not this one. This one's for rectangle. Any rectangle that we have, we can take that rectangle and, can you see these?
A little blue lines that are shaking.
It's almost like it's on graph paper. Yeah. I can cut this rectangle into a whole bunch of squares. Okay? Yes. Your rectangle on your paper should look like this. Maybe not as many squares, but draw a rectangle. Okay? We can separate this rectangle into squares. So maybe like that. Those squares are a little bit more, so you don't have to draw all 100 of these squares. You can draw 6 squares like that. Okay? I want to add all of the area that I've just created, right? We just said we can take area, or we can take a shape and separate it into 2 separate shapes and then add those areas together. So every square that I've created, okay, can be a different area.
So like the blue ones are the same area, but they're different green ones.
I just didn't want to color every shape the same color. No. All of these are squares and they all have the same area. Okay? So, if this was a rectangle, or this is a rectangle, we know that the formula is length times width. I'm giving that to you. I'm not taking it away from you. You already know it. I'm giving it to you. I can add up all of these. How many is that?
3.
3. My length is going to be 3, right? I'm adding up everything across the length. There's 3 of them. How many do I have on the width part?
2.
2 of them.
Wait, is this kind of like the thing where it's like you want to find? I used to do it. You count like across and then multiply down. And
Yes, that's exactly what we're doing with rectangles. Yes, because all I had to work with right now is squares. Yes. So area is equal to length times width. Well, if I add up all of these squares, I'm going to get 6. 6 squares. How did I find that though? 3 across the top and there's 2 across the bottom, right? 3 times 2 is going to give me 6. That's where the area formula for a rectangle came from. We separated it into a bunch of different squares, and then we got the rectangle. Does that make sense? Okay. So this is one way that we're going to try today. And another way is I'm going to show you with the triangle. Okay? Are there any questions on the rectangle one? Okay, so on your paper that you have, you should have my 3-box by 2-box rectangle drawn. Everybody have that?
Weird, I made mine 50.
Oh, okay, that's fine. Alright, so let me go back here. And let's look at triangles. I think I only want to use one triangle. So let me use my small triangle because I can move it better. Okay? So what do you think we can do with a triangle if all we have to work with are rectangles and squares? I have to use those formulas because that's what I know.
You're gonna make your height line.
I'm going to make my height line. Okay, which one, Sam, do you know is my height?
It's kinda hard to explain because I don't know how to say it.
Alright, I'll come back to you, hold on. Because I don't have heights in my squares, right? I have to either be using a square or a rectangle right now. So you know?
I was gonna say add another triangle, but
Add another triangle and put it where?
on like top, like
Flip it and put it
on the graph.
Yeah, I think I can do that. So we're gonna copy it, clone it. Copy or clone? Let's clone. And then we're gonna remove it so that it looks like that.
and then it makes a rectangle.
Yeah, it's either gonna make a rectangle or a square. Because I copied it and because I cloned it, what do I know about these two triangles? They're exactly the same, right? So if this is now a rectangle, we'll call it a rectangle. I would do area is equal to length times width, right? Because I made a rectangle. Okay. Let's think about though, this was the triangle I started with, so that's the only area that I need.
So you don't need both of them?
So I don't need the whole length of my area. How much of my area do I need?
Half.
What?
Divide by, did you divide
Yeah.
by 2?
Yeah. Area equals half of that length times width, but L and W don't match up with B times H. How am I going to figure that out? How can I replace L and W with B and H?
Length is height and base is the width.
One of them is my base and one of them is my height, right, Sam? We just had to figure out where that right angle was. Maybe if I gave you that, that would have been easier to figure out.
Yeah, because the height on a right triangle is the,
What is it?
the liney, like,
And what does it do with the other liney thing?
what other liney thing?
This liney thing
Yeah.
and this liney thing make what?
A right angle.
A right angle. So our height is always perpendicular,
Perpendicular, you're right.
to our base. So then we think that this is our height and this is our base. Perfect.
That
So
would be
area
right.
is equal to 1/2 times height times base, or times, we talked about this yesterday. How come I can rearrange these two things down here? What is that called?
Because you're still.
It's called something.
Commutative property.
Commutative property. So we do, we have 1/2 times base times height, and that's what Zach wrote up on our board for area of a triangle.
So what do we write down?
So what do you write down? I would write a triangle, and then I would draw a second triangle, like that, so it looks like a rectangle. And then I would write all of this stuff. So we took area equals length times width because it was a rectangle, but the only part we wanted was the original triangle, which is half of that rectangle.
So are those like the steps?
Yep.
In order?
Are we gonna do
That's
this
how we
with
got
all
there
of
to
them?
that formula. Okay, feeling a little bit better?
Is this our
Now our page is not blank. Yes.
Yeah,
this is
and
our
it's
actual-
colorful.
And it's colorful, you have markers, yes. Question?
Are they all gonna go back to the rectangle?
They're either gonna go back to square, rectangle, or now triangle, okay? And there's not one way to do all of them, alright? So, your group may have a different idea than their group, and that's fine, as long as we get the same answer.
So are all of them commutative except for trapezoid?
The commutative part, yes, is either multiplication. Trapezoid has commutativity inside of the brackets, right? B1 plus B2, it could be B2 plus B1. And then I could say 1/2 times that quantity times H, so they all have commutative somewhere. All have. Okay, so let's try next, your job. Let's try a parallelogram. Think about, we have two things that we can do. We can take our, I can't bring it back up because it's gone, but we can take something and split it into different parts, and then find total area by adding, like we did with rectangle. Or we can take something that we have and reproduce it, and add it to it, and then take it back away, right? So let's try that with parallelogram. Get a partner that's next to you. You can move your desks. Yeah. Yes. You now have square, you have rectangle, you have triangle to work with. You have those three formulas that you have to find everything else with. So parallelogram, you have 3 tools right now in your tool belt. Like I have 3 markers. You have 3 tools. So use those tools, figure out parallelogram. And then we're going to talk about why parallelogram and rhombus are alike. Yes?
No.
Alright.
How do you know?
Split it up into 2 triangles.
Hold on. That's not just that. Hold on.
He just said you can split that. Actually, you can split it on 4.
How would you
No,
split it?
1, 2, 3.
Is there
2 diagonals.
Okay, we're gonna do 2.
Okay.
There's more than one way to do all of these.
So can you do like triangles outside?
Wait, what is?
Absolutely. Because we did hideout back then. Dawson is.
So then,
Tell me why.
This is
there's no right. But I know that's the height. Oh yeah, there is right here. That's a right angle. That's a right angle.
You must be crazy.
Mine makes a right angle.
Or a rectangle.
like,
Okay.
So then it would be.
Mine's a right angle. So there's the height, and there's the base right there.
That's not a right angle.
Yes, I made a right angle. Look.
What do you think about this? Hold on.
I just made a right angle.
You have base and height.
Literally, flip your paper like this.
Kind of, but you have to know why.
It's because your line isn't straight, so you can't see it.
So that triangle and that triangle should match. Why?
Because of the right angle.
Because they're right angles.
Because they're perpendicular to the right angle.
Then share that side. How about this?
That's the original.
They're the same height.
They're the same height, so yes. So these
Those are
triangles are the
parallelogram like
same.
they all do.
That's the parallel and triangle are not in the same, are not in this picture. So when I calculate this area, I have to take that part away.
Switching it on a.
When I take it away, what part am I taking away?
Yeah, because
That's what
parallelogram.
we're trying to figure out.
Wait, those
Are we just doing parallelogram?
We're gonna do parallelogram for like 2 more minutes, and then we're gonna do another one.
Can you check this?
See if we actually
Um,
this somewhat right.
Ooh, you're the only one that did that.
Oh, what I tell you?
Ooh, in triangles?
Yeah.
Yeah. Now, why do you know that these triangles?
Hey.
Wait,
No,
actually,
okay, yeah,
she
that's
didn't,
what I-
she didn't answer the correct question yet.
But these triangles, what do you know about them?
They're congruent.
Why?
Are we diameter? Or no, they're split by a.
So they share that. So that's one side that they share.
And then
So
that's
I need.
alternate interior.
Ooh, that's an angle. So I've got side angle. I need something else.
Side angle and
What about the sides in a parallelogram?
they're
We don't know.
Oh, they're equal. Yeah,
Which
so
ones?
like, boom, boom.
opposite sides.
Boom, boom. So Zach told me this side and this angle, and then how about this side? Because then I would have side, angle, side, right? So these 2 triangles are the same, but I've got 2 of them.
So these sides would be the same.
Yes. So you're right. These are both, they're congruent, but I have 2 of them. So what did we do with our postulate 19 just now?
We added them together.
We added the area of the figures that are in this, in here, right? What would that look like? I know I can't really fill in H and B right now.
So it looks like a,
Did you just do triangle 1 plus triangle 2?
Yes, but what would that look like? So you've got area equals 1/2 base times height plus area equals 1/2 base times height. Add those things together, and then tell me what you get. But later, not right now. Tell each other what you get. What are you doing?
I think it'd be good.
Can you explain why you can get
I didn't feel like
from that?
That's
Ask her if they have these triangles. I don't know if these. I'm gonna try telling you that. Is it like, okay, so we split this thing? Yeah,
I don't know the right angles though.
That's a right angle. She just said it's side angle, so. Side angle, side.
There's only one right angle. There doesn't have to be two right angles.
No, it's not this, it's this angle. These angles.
Oh, I see.
She said you add these together.
I think so. Yes. So you have to prove
I
why
don't know
these
about
triangles are the
cross-sucking.
same. Okay. Yes. Yes.
Well, would this be it? Base times height, and then in parentheses take those. Yes, yes.
Kinda. What
I don't know
happens if you
I don't
take
know.
if you take half base times height plus another half base times height? How many base times heights do you have?
2. 2
No.
you square.
You have half plus half.
That's one.
You have one. So what is 1 base times height? What does that look
Just
like?
base times height.
It's base times height. What's the area formula for parallelogram?
Area equals base times height.
Please pardon the interruption. At this time, Mrs. Crumpleman's ACT group should report to the Arlinghouse house. Mrs. Crumpleman's ACT group to the Crumpleman house. Thank you. Or to the Arlinghouse house, sorry.
What do you want me to draw for you?
Yeah, it's like here. You have pencil? No, there you go, pencil.
Okay. She said, okay.
Okay.
I've been raising my hand for like.
Oh, sorry. Same way.
There.
She said, I'm.
You write it? Oh, I didn't realize you gave me. You took the lead out of it.
You took this triangle.
What?
Okay, so I saw lots of different things with parallelogram. Here's the one that is the quickest, so I'm going to show this one first. And Jana's group and Zach's group had this. So Jana or Zach or Maggie or Adam, tell me what I'm doing here.
Gotta split the diagonals,
And that's 2 triangles.
and then it'll be side and side.
So you do base times height.
Okay, so, okay, good. So our area addition postulate just said if I can take area plus area in the same figure and then get the area for the whole figure. So in this triangle, I don't really know what the height is, and I don't really know which one the base is right now. But I know that it's 1/2 times base times height, right? For area of number 1. Area of number 1 is equal to 1/2 times base times height. Everybody with me?
Mm-hmm.
Yes.
So number 2, make it blue, is also 1/2 times base times height.
Then it's
Add
just
those
base
together.
times height.
So if I add a half plus a half,
1.
how many base times heights do I have?
Just 1. So it'll just be base times.
1 base times height, right?
So then it would just be base times.
So it would just be base times height. So the area of the whole thing is base times height. Yay! Get it?
Yeah.
Are we going to be that like Amos and I did with the?
Yes. So that's one way. Okay? I can also take a parallelogram. Let's see if I can copy this.
Can we keep
I
that
did
up
take
there
this
so I
one.
can write it after we write this one?
Yes, I will keep it up right now. It's still there.
I have more.
Okay? So this parallelogram, this is how Sebastian did it, and I think this is how you guys were doing it. This is how you should have done it. So I know that you drew the triangles. Okay, you drew this triangle in, right? Okay. And then you drew this triangle in, correct?
Yes. And then I put in the other one.
I cut off.
Oh, so you did it the same way.
That could have been easier.
Yeah, we made
You
squares
can
on the
get
top on
3
that side.
triangles out of
Turn it into a big
Those are
rectangle.
Do you want me to
Yeah,
draw
we did
it?
that
I'll draw
outside.
it.
Those are heights.
Hold
I
on.
know, but you can.
Hold on. Everybody hold on. Come back. Come back. So if I draw this triangle inside, and then I draw this triangle outside, okay?
You feel like a
This triangle is part of my parallelogram, correct?
Yes.
This triangle is not, correct?
Yeah.
Okay. But if I take this triangle, and I cut it off of there, and then I put that in this space, why do I know that those triangles have equal space or equal area? Okay, if these are parallel lines because it's a parallelogram, this height is the same, yeah. So those sides are the same. If it's a parallelogram, this side and this side match, right?
Yeah.
So then these sides are the same. If I have a right angle, okay, then I've got hypotenuse leg already. I've got the hypotenuse and the leg that are congruent. So these triangles are congruent. So if I take it off of the parallelogram here and I stick it on the outside here, my shape now looks like a rectangle. Okay? And the area of a rectangle is base times height. Or length times width, right? Yes.
Would it be like a wrong way to do how you did it on the outside but to the other side?
Like make 2 triangles on the outside.
If you make 2 triangles on the outside, you've got to start subtracting area. And then you've got to be proving why those triangles are the same size. So these 2 ways are the most efficient. You can probably do that.
Wait,
I don't-
some way.
The way you did it was right, because this is what Candace told you. Put it on the outside. Okay? Questions on parallelogram? Questions on parallelogram?
Nope.
Okay.
We're ready to start another one.
Next one. Our next one is a rhombus. Before we do what we just did with parallelogram, let's think about rhombus.
Can you go back real quick?
I'm sorry.
I think you raised it.
So let's think about a rhombus real quick. What do we know about a rhombus? What are things that we know about a rhombus?
All 4 sides the same.
Okay, yes. What else do we know about a rhombus?
It can be made of stupid.
We can split a rhombus into 2 triangles. That's true.
No right angles.
I don't have any right angles until I draw in my diagonals. That's true.
Oh, yeah.
What were you saying?
I just said a diagonal on this. I'm sure to-
Or perpendicular.
You're good now.
Good job.
Isn't that opposite angles are equal?
Opposite angles should be equal to each other. If I wanted to take a rhombus and say that a rhombus is another shape, what would I call it? Can't call it a square because it doesn't have 90-degree angles. Can't call it a kite
Because they have 3 different angles.
Apparently.
because a kite has only 2 pairs of things that are the same. I could call it a parallelogram. So the formula that I gave you yesterday of area equals 1/2 times diagonal 1 times diagonal 2, that's going to be a little bit more complicated than what we could use, right? Couldn't we just use the area of a parallelogram, that formula for the rhombus also? Yes. Let's change our minds. So I'm changing my mind. For area of a rhombus, because we can do the same thing. I can split my rhombus into 2 shapes, find the area of one, add it to the area of 2. They're both triangles again. So we're going to have the same thing. Area equals 1/2 base times height.
Wait, is that the equation we're using from now on?
Yes,
So not that one?
correct. We can use either one. Sometimes I might give you the diagonals. That's our backup plan. But this one's going to be easier for us. So let's just remember this one too. And then plus the area of the second one. 1/2 times base times height. So the area for my rhombus is, again, just base times height. Okay, so let's put that on our board also. Not only is the area formula for a rhombus 1/2 times diagonal 1 times diagonal 2, but also area can be equal to base times height. Okay?
Give me the options, right?
Questions on rhombus. So you can use the same picture that you have for your parallelogram to describe rhombus. Okay? Kite is going to be a little bit more complicated. So I'd like to go through kite with you. Oh, I don't think I drew one. I'll come back to kite. Let me do trapezoid first because I drew a trapezoid. I drew a trapezoid. Well, they drew a trapezoid. Does anybody have any ideas about trapezoid? If I draw a trapezoid like this, does anybody have an idea about that trapezoid? What could I do? Yeah,
You could like make triangle bottom.
like here?
Sam was thinking a different way. And then it's a rectangle in the middle.
And then there'd be a rectangle in the middle. Very good. Sam, what did you have?
You can also create outside triangles to make it another region.
I could also create outside triangles. That's what Kylie and Dawson were doing. And then I would be subtracting. I want to show you something else.
You put in the two fronts, like on the parallelogram, like did the diagonal.
Except for sometimes I have a trapezoid that might not look that way. Sometimes I have a trapezoid that looks like this.
Use that posh.
Oh wait, it
Well,
would,
what couldn't you still do two triangles?
that'd be a square or one and a square.
How would I find the triangle to put there?
Oh, yeah.
So, my hint says think about what we did with the triangle. What did we do with that one?
We made.
Wah! Sam, raise your hand, yes.
We added another.
We added another triangle. Let's look at our trapezoid.
We added another trapezoid then.
Well, how do you...
1, 2, 3,
Make a
4,
hexagon.
5, 6, whatever, a hexagon.
Hexagon.
But this side disappears, so let's watch. So if I clone this and I make another trapezoid, and I flip it,
Then you just have something without a line.
It's a parallelogram.
Oh.
what is it, Sam?
Oh.
Parallelogram.
Okay, that's smart.
Look at that.
Base on height?
Look at that.
I thought you put on the,
Two bases times the height.
Okay, that's for like an isosceles trapezoid. Let me show you this guy. Because I can't
It
do
would make a
that.
rectangle.
It would make a regular trapezoid because
This is a parallelogram. I don't
No,
write
the one at
it.
the bottom.
It wasn't add them together.
Possibly.
And then finally.
Can I take out the triangles? Yeah, I don't know. This is what I did. I took my trapezoid and I made it, and I copied it and put it on the end of the trapezoid. So I've got two trapezoids. Okay. But that didn't give me my formula. So let's think about how my formula comes from this. So I need to go from, this is a parallelogram, that's area equals base times height. I need to go from there to area equals 1/2 times height times base 1 plus base 2. How am I going to do that? Ideas?
We're gonna need a triangle at all there.
Not if we do this.
Wait, how would you? Can you just like? I don't know how to explain it without like.
Do you see how this is 1 and this is 2?
Yeah.
And if I add them together, I've got a parallelogram. So my area is base times height.
Yeah, I understand that, but on
Okay.
the second one, couldn't you just draw like,
Break your will.
you know, where it like goes points out a little bit?
Okay, here. Are you talking about my red one?
Yeah.
Okay.
Go over to like the very end. Could you draw like a line going up and then over?
We could. Yes, that's another possibility. So let's focus on this one. How are we going to get our formula?
Since you.
How are we going to get our formula?
I'm gonna do like the parallelogram and do like the base.
Yeah, like what happens, don't you need 2 bases?
We need 2 bases. How am I going to throw my 2 bases in there?
Could you, or are you gonna have to subtract stuff, like could you add another A equals,
Let's think about this half first. Where does that half come from?
Are you gonna have to split it?
Yeah, because I added something that wasn't there to begin with. So I really only want half of that anyway. Okay? So area is going to be half of the base times the height. Half of that. Okay? Well, there is 2 bases. So I need to take half of the average of my bases. So this base is going to become half of the average. So 1/2 times height still. But I need to be adding those together when I divide by 2. Because I have 2 different bases.
That was
okay,
put numbers in there.
Okay. Base 1 plus base 2.
No, like actual numbers.
I know, I will.
Okay.
This is the formula.
you just wrote the same thing again, I think.
What happened to the base?
Oh, you could say.
Here's 1/2.
Okay.
Here's height. Okay.
There's
2 bases.
bases.
How did this base get to be this base?
There's one on top and one on the bottom.
I can't, I only had 1, right?
I'm so confused.
Okay, hold on. In my trapezoid, I've got 2 different bases. If I want to use one base in a formula, I'm going to have to find the average of that, the middle of that. The middle of that would be if I add two things together and I divide by 2, kind of like a midpoint, right? If I add those two distances together and I divide by 2, I get the one in the middle. That's what we're doing here. We're going to take half of both of those bases. So I can't just do one, because that wouldn't be fair for this one.
Splitting the base into two? I'm so confused.
So a trapezoid has two
Sort
different
of.
numbers for a base. When you take them and put them in a formula and you add together, you get them to be better too.
No.
I have one good question.
So look at this, Maggie. If this is a parallelogram, what's true about this line and this line, the whole thing?
They're parallel.
And they're equal. It's a parallelogram, right? Yeah. In a trapezoid, if I only have one of my trapezoids, is this line and this line the same?
Please pardon the interruption. Joe Natixburn and Kevin Kusick come back to the office. Joe Natixburn and Kevin Kusick.
That's what makes it a trapezoid, is they're a parallelogram. They're not the same. I need to find the middle of that so that when I do this base times height, I'm not taking just one of my bases, I'm taking both. So if I want both of them, I have to put them both in my formula. So I'm just taking this base here and making it base 1 and base 2.
So you're kind of splitting the top line into two.
I'm taking these two things, adding them together, and then dividing by 2, yes.
We'll talk later, I know what I'm talking about.
We'll talk later. That's trapezoid. Anybody else have a question on base 1 plus base 2?
Yes.
Yes.
How do you, does the second base just come in?
Yeah. I can't have only one base represented, right?
Like, yeah, I get that part. Like, I get where you get the first B1 from. And then do you just add the second B from like the top equation?
If we look at B1 though, if we were doing parallelogram, this would be B1, the whole thing. Okay, but it's two parts.
So you're taking half of B, right? So you
Oh,
take
okay.
B2.
I get what
In my first trapezoid, this was
So
B2, and this was B1 in my first trapezoid.
Yeah, and then
When
you
I
added
copied
another
it,
So you
wait, let me talk. When I copied it, I made this be base 2, right? Because I copied it and I flipped it. So this length is actually equal to base 2.
That makes sense.
And like I know what you're talking about, we talk about.
So if I was going to take the area of this whole thing, it would be base 1 and base 2 would be replace my B. Kylie?
I
Right?
got it now.
You got it. Okay. And this would be base 1. Okay. Let's save kite for tomorrow. Monday. Let's save kite for Monday. Make kite your homework.
I'll try.
On the back of this paper, it says, choose 2 area formulas and write them below. I don't care which ones you choose. Okay? Don't start yet. Hold on. Choose 2 area formulas and write them below. I want you to compare these 2 formulas. I want you to think about what we did in class today. So every formula that we got, with the exception of kite, so don't choose kite. Every formula that we got, we used a different shape to describe how that formula came about, right? Correct? Yes. So think about what we did in class today. How are these 2 formulas the same? Or how did I arrive at both of those? So if you choose rectangle and you choose parallelogram, why are they similar?